Hi everyone, welcome to Math Moment with Mr. Dustin. I am Mr. Dustin, and welcome to Summer Reading 2021. This is the first of our 10 virtual math programs for this year. And in these programs, I go over a math concept that's really helpful for middle school and high school math, and we just kind of casually review or learn about one of these concepts. So in today's lesson, I'm going to be going over what I'll be doing for the summer and kind of what that looks like. And in the second half of it, we'll be looking at some visual growth patterns. And so this will kind of get you into the mindset of math and really kind of challenge you potentially. We'll see. So to start off, we're going to go over like what math is and some of these like subsections of math. So first of all, we start out with math. Well, you hear math and you have most likely studied math. So, what is this about? So the formal definition is that math is the abstract science of number, quantity, and space. So realistically, all you need to know about that definition is it's really just the study of numbers. You add numbers together, you subtract them, you can multiply, divide. Those are basic operations. And, each of these numbers may represent a quantity, and that is the word used there. And then eventually you'll get onto looking at these numbers or quantities in terms of a space. And so we're not going to get too much into that, but I figured it would be a good idea to kind of see what this definition is and what are you really working with in math. And now there are some subsections of math, and this is kind of where or how our lessons are divided up this year. So I have like 3 at the beginning here that are going to be talking about various numbers. We're going to be studying fractions specifically. And then we're going to go into an algebra section. Now, algebra is a subsection of math. So what is algebra? It's the part of mathematics in which letters or other general symbols are used to represent numbers and quantities in formulae and equations. Now, that's a very complicated and long definition. So I have a simpler one over here. It's the use of symbols to represent numbers in equations. So essentially, you'll take a number and replace it with a symbol. And that symbol could change, or well, the symbol doesn't change, but the number in which that symbol stands for could change. And we'll kind of go over what that means. And just to be clear, an equation is a statement showing equality between 2 or more expressions, which are these parts of these statements. So you can see in the bottom corner here, we have an example of an equation. And you can tell it's an equation because of this equals sign here. So you've got one expression, which is the 3x plus 4, and then you have another expression, which is 28. Each of these parts alone doesn't mean much of anything. And so with this equal sign, we're making a statement. If you were to say it in plain English words, you'd have 3x plus 4 equals 28. That is a complete sentence, and so that's our complete statement there. Now, there are these different parts of the equation. We have what is called a variable. So we're going to go over what a variable means in one of the future videos. But for today's purposes, we see that the variable is x. And notice that is a symbol or a letter that is replacing a potential number. And what this means is it's multiplied by the 3, which that term is a coefficient. Now, obviously, there are a lot of terms coming up here, and it doesn't matter quite so much at this point, but it's good to kind of see them and where they're applied. If you hear them in the future, you may say, hey, I heard this in Mr. Dustin's video. And so the other important term is a constant. And this is just a number not being multiplied by a variable. It's just by itself. It's a constant, unchanging, because the variable is changing. And that's why you could consider it like, variable, that kind of thing. Algebra is also applied to graphs, and these equations represent different lines that we can plot. And so that's kind of what we see over here. And I don't know that we're going to get into this aspect all that much, but you can see that's how it's kind of applied. And then obviously these symbols up here are very important to algebra and even geometry, which we're going to get into right now. Now, geometry is the branch of mathematics concerned with properties and relations of points, lines, surfaces, solids, and higher dimensional analogs. Now, there are so many terms in that, I'm not even going to begin to go over that. Instead, let's just stick with our simpler definition. Geometry is work in math considering lines, points, and shapes. Okay, so a point, pretty simple there. You can see these like A, B, C, and D are points. Then you have lines, and these are, as they look, they're lines, and they connect 2 points or 1 point, and it goes infinitely in another direction, or a literal line, that's the actual term, and it'll go infinitely in both directions. The more interesting part of geometry is the shapes. So this is something we will go over later on. We'll go over 2-dimensional and 3-dimensional shapes. And so 2-dimensional shapes are kind of these triangles, your squares, your circles. And then you have 3-dimensional shapes, which are the pyramids and the cube, the Rubik's Cube. And there's also the sphere, which for the Earth specifically, if you were to have like a physical sphere of the Earth, we'd call that a globe. And so we'll do about 3 videos on geometry as well, going over the different shapes and some triangles, because triangles are very important in geometry. So now we're going to take a break. During this break, I'll demonstrate how to work with Beanstack, which is the program that we're using for our summer reading activities. So it is very important in terms of getting credit for like watching these videos or your reading, and it'll keep track of prizes and everything. So I'll show you how to make an account, and if you're a parent watching this, I'll show you how to add children to your account so that everyone can get a prize at the end of this when they register for summer reading. When we come back, we'll be looking at visual growth patterns, and I'll explain what those are when we come back. Welcome to the break session of this math video. In this one, I'm going to show you how to register for the summer reading program through Beanstack. And so this is the library website. I've gotten to Howard Miller Public Library, and it's like the first thing that pops up when you do a Google search on it. And so this is what it looks like. And you can see, you can get to our catalog and everything. But if we scroll down a little bit, we find Beanstack. And that is the program we are using for summer reading. So I'm going to click on it, and it's going to prompt me to go to this page. Now, there are a couple of steps we can take here. And there's obviously the sign in button at the top here, which if you have an account, that's what I would recommend doing. You can sign in with your email or username if you remember that, but email would be the easiest way in my opinion. And then your password, which if you forget your password, obviously there's a way to recover it like that. As far as making an account goes, you can scroll down to below our title page here, and you can see create an account, register an individual or family. So to do that, you'll click on that button, and it'll ask you, have you previously used Beanstack to participate in a summer reading or in a reading challenge? And you can answer yes or no. I'm going to say no, just for the benefit of those who have never used this before, even though I personally have. Now, it'll prompt you to register either yourself or a child. Now, the first thing you'd want to do is register yourself. So when you do that, it'll bring you to the screen and say, first name, last name, and all that information. So I'm going to fill that out. And then it'll prompt you for a username or email. Well, I'm going to do an email at some point. And so once I'm done with all this information, I will cut to the next section of it. All right, now that we have an account with Beanstack, this is what it's going to look like when you log in as an adult. So you can see that it gives you these challenges, and it'll have these tabs at the top here, and we'll kind of go over them briefly. But first, for registering children, so I can see myself here if I click on this, and my fake children from Star Wars. And then if you want to add children, you just hit add reader. And so then it prompts you with the same screen as before. And you could say, I'm an adult registering a child, or if you have another adult in your family that you'd like to put under your account, then you can say, I would like to register another adult. So usually what's going to happen is people are probably going to want to register their children. So it'll prompt you with their first and last name, which are required, and then their age, which is also required, and school. Now, gender is not required, but it might help. I don't really know what we would use that information for on the back end of it. But once you enter their information like this, it will also prompt you for a grade they're entering. So let me just come up with a random Jedi real quick. We'll say, yeah, Master Plo is 6. And then we'll say for school, there's an other option, so that's kind of helpful if you don't belong to any of the Zealand public school, districts. And for gender, he's a male. So next. So then it assumes the grade level that your child will belong to. So kindergarten through 5th grade is the one that Master Plo is eligible for. And so we can see I have these other children here, and I'm going to kind of look at the different grade levels and go over the challenges available to them. So let's go to Anakin Skywalker challenges. Now this is a preschool child, so babies through preschool, and you can see they have 2 challenges here. So I'm going to click on that, and all you have to do to register is hit join challenge. I'm not going to do that because that's going to throw off our statistics, but if you join the challenge here, then the child will be enrolled in said challenge. And then if you have enough readers, it's going to prompt you with change readers, and so you can select from the list here. We'll go with Master Yoda. Now this is entering kindergarten through 5th grade, and so it's the same kind of prompt, join challenge. You click on it there, and you'll be all set. And then same with the teens. Click on it, join challenge. There it is. And then it'll have everything pop up for you. Now, since I personally am in a challenge, we'll go look at my screen. Now, let's say you're enrolled in a challenge. It'll have, so-and-so's challenges. And so you can click on it again, and it'll bring you to an overview of the program as well as your overall progress in terms of like earning badges and everything like that. So in the case of the adult challenge, you have books that you need to read. So if we click on that, obviously I haven't read any books yet. Registered for this like yesterday, so not enough time for me personally. In order to log reading and activities, you want to go to this blue box at the top here, and it'll say, who do you want to log for? So I'm the only one enrolled in a challenge at the moment, so I'm going to log myself. And for different children, it'll have different options. So some will have log books and others will have log minutes. I only have log books here, so I'm going to go in and say, hey, I read a book. The title is optional, the author's optional. Prompts you if you'd like to include a review. That's not necessarily for everyone, but you can if you'd like to. And then all you have to do is click log, and it will keep track of everything for you. And that's how you complete the reading challenges. There are also activities that you can log. So instead of saying log books or minutes, you can say complete an activity. And all you do to do that is click on the box to have it be applied to your total for activities. And so that's really all there is to this. And feel free to ask the librarians at the desks about these challenges or anything like this, if you have any questions, feel free to give the library a call as well. We are always happy to help. And so I'll send it back to myself for the rest of the math portion of the video. Hi everyone, welcome back. I hope you enjoyed the break and found it informative and helpful for signing up for the summer reading program. So we're going to get into visual growth patterns. And this is basically where I'll show you a pattern and we want to see how it grows. And so we'll give you like a first step, a second step, and a third step. So I can kind of label this first, second, and third. And we're going to see how it changes. So this kind of combines algebra and geometry, so that's why I wanted to do it. And so for this first one, we want to say how many people fit around the table. And so this table here is essentially these sticks. So you can see in this first one, we can fit 1, 2, 3. So we know there are 3 total people, and I'll change color. Let's see. There we go. 3 can fit around that first table. All right. What about the second table? 1, 2, 3, 4. So we can see that there are 4 people at the second table. Now, what about the third table? Let's see, we'll go red this time. 1, 2, 3, 4, 5. So there are 5 people at this table. Now, how do we predict the next one? How many people are going to be in the fourth step? And I'll give you a moment to think about it. And without drawing it, I'm just going to let you know that this is going to be 6. Now, how do I know that? Well, there are a couple ways we can look at this and kind of see, oh yeah, this makes sense. So the first is that, well, we start at 3, then we go to 4, then we go to 5. So if you're counting, that's going to be 3, 4, 5, 6. That is in order. You're increasing by 1 each time. Another way to look at this is through an equation, and that's going to predict what happens in the next few steps. So what I'm going to do is I'm going to let n be equal to, let's see, the step number. And so then I'm going to say, okay, all right, let's say n equals 1. So 1 is the first step, right? Well, if I want to predict how many people can fit around the table, we'll call that P. I want to say P equals, wow, that's a big equal sign, n. Now, we know for the first step that P is equal to 3 and n is equal to 1. So is 3 equal to 1? The answer is no, it is not. So we need to adjust this equation a little bit to fit for what actually happened in the first step. Now, how do we get from 1 to 3? Well, we can add 2. So I'm going to do that. I'm going to say it's a step number plus 2. Now, what that's going to do is it's going to say, hey, let's say 1 plus 2, and we know that's equal to 3. How about for the second step? Well, we know 2 plus the 2. And remember, I just put this 2 in for n because n is that step number. And that is equal to 4. Now, okay. Does this really work for the third one? We got to be absolutely certain. So I'm going to put 3 in for n because that's the step number, 3. And then we add 2 to it because that is a constant. It is always going to be like that. And we notice that is equal to 5. And so our steps have been consistent with our results there. So that shows us that the equation we came up with, p equals n plus 2, is the correct formula to predict any of the next steps, and we don't even have to draw them. Now, I'm going to go over the next one, and so we'll do the same kind of process here. We want to see how many smiley faces there are. So I'm going to do step 1, step 2, and step 3. Well, let's see how many smiley faces are in the first step. We have 1, 2, 3. That's a coincidence that both of these steps, or first steps, have 3. How about for the second step? We have 1, 2, 3, 4, 5. Oh no, this is a little different, isn't it? How about for the third one? 1, 2, 3, 4, 5, 6, 7. Now this is a little bit of a different pattern. I'm going to use the same variables as the first problem, and we want to predict how many. Actually, I'm not going to use the same variables because I want a different one for smiley faces. So we'll say S equals smiley face. There we go. So let's see. S equals N. Well, for step 1, we have 1 here, but S is equal to 3. So that's not right. We can't do that. Now, if we add 2, we get it right on this one. So let's try n plus 2 like we did last time. So now if I want to test it for the second step, let's see. 2 plus 2. Now wait a minute. That's 4. We need 5. So that equation doesn't work. Let's try a different method. Now, this one may be a little harder to see, so I'm going to kind of fill it in like this. We're going to do something like this. Now, what this equation means is that we're going to multiply the step number by 2 and then add 1 to the total. So for our first step, we're going to say 2 times 1 plus 1. And you'll notice if we do this, 2 times 1 is 2, and then 2 plus 1 is 3. Okay, that works. That works pretty well. What about the second step? So we want to do 2 times the step number, 2, plus 1. Now 2 times 2 is 4, and then if we add 1 to it, we get 5. Now what about for the third step? We got to be absolutely certain. So we want to say 2 times 3. That's the third step. Plus 1. And that's going to be equal to 7. And that's because if we do 2 times 3, that gets us 6. And 6 plus 1 gets us 7. So we can see that this pattern here works, this equation. Now I have 2 more on here, and I'll share the link to this Jamboard in the description of the video. And what you can do is you can try these on your own. The one on the left is a lot like the 2 that we just did. And then the one on the right is a little more challenging. So for high school students watching this, I would recommend you try the one on the right. And I'll give you a hint. It is not linear. What we just did is linear. So try to think of things that are not linear. You might know exponentials, you have the inverse functions, or you have quadratics. So if you're in high school and you want to challenge yourself a little bit, I'd recommend trying the one on the right and try to find the pattern for it. Additionally, I also want to see if you guys can guess the 10th step. So however you want to do that, if you want to write or draw out all these continuing patterns to guess the 10th step, by all means, you can do that on your own. Or um, if you want to use an equation like we did on the previous slides, feel free to do that too. Now, to summarize everything we've done for today, we know that algebra is the use of symbols to represent numbers and equations, and then geometry is work in math concerning lines, points, and shapes. And we have 3 video sections for the summer. We have part 1, which is going to be fractions, which is releasing today. And then we'll continue for the next couple weeks. And then we have part 2, which is algebra, which will be a couple weeks in July. And then part 3 is geometry, which will be the last few videos for the summer. So we also have a quiz that you can complete, and I'll put the link for it in the description. Quiz available. So the link for that is in the description of the video, and feel free to take that and let me know what you thought of this lesson. There's a question on the quiz about that. And be on the lookout every week for more math videos, and I look forward to seeing you again next time.